Alright, so for number 5, we're going to be graphing, actually for 5 through 21, or 5 through 19 at least, we're going to be graphing some functions, and each one has 3 different functions within the same problem, within the same family. So number 5, we start off with f of x equals x, which I already have on the graph. It's a line, slope is 1, y-intercept is 0. And again, you can look at your booklet and it's the linear function. G of x is x minus 4. So what happens is the graph of f of x got translated down 4 units. So this line right here is going to go down 4 units. So instead of 0, 0, it's 0, negative 4. And then it has the same slope, right? So it's going to just go across this way. And this, let me extend it to the left a little bit. And this is g of x. H of x has a vertical stretch by a factor of 3. So that means that the y's get multiplied by 3 on the parent function. So instead of, well, 0, 0 is going to stay 0, 0. So I'll put it right here. But instead of 1, 1, like you see on the blue line, instead of there, it's going to be 1, 3. Instead of negative 1, negative 1, it's going to be negative 1, negative 3. So connect those points. I can't use a ruler on this, but they're supposed to be lines, okay? Sorry about this. This is kind of a curve. Let's see if I can fix it. Okay, so it's 3 straight lines. So this is h of x. Okay, for number 7, I've already got the f of x function on the graph. F of x equals x squared. That's the same one from your book. It's a parent function. So for g of x, it's x squared plus 2. So that means there's a vertical translation 2 units up. So every single point on this blue graph is going to be moving up 2 units. So here, 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 and here. Connect your points. And there's g of x. Now, h of x is translating to the right. You know how it says x minus 2 in parentheses? So you go to the right 2 units. So every single point on the blue curve is going to move to the right. So the 0, 0 is now at 2, 0. The 1, 1 is now at 3, 1. The negative 1, 1 is now at 1, 1. So there's an overlap right there. And then 2, 4 is now at 4, 4. It's going to be kind of messy. And then negative 2, 4 is now at 0, 4. Okay? So we're going to connect the 5 points. And this is your h of x. For number 9, I have f of x on the graph. It's negative x squared, so that means that the parent function reflected over the x-axis. Same exact shape as x squared, it's just reflected over the x-axis. So for g of x, it's negative x squared plus 1. So after we reflect, which we have right now, we're going to raise all the points up 1. So you're going to have 0, 0 is now 0, 1. And negative 1 is now negative 1, 0. 1, negative 1 is now 1, 0. And negative 2, negative 4 is negative 2, negative 3. 2, negative 4 is 2, negative 3. So everything went or moved up 1 unit. So the graph would be something like this. And that's your g of x. Okay, for h of x, we have the opposite of x plus 3 squared. So again, it's still reflected, so it still starts off like the blue graph, like f of x, but this time we're moving to the left 3 units. Okay, so we're starting off with the blue graph, but then moving it to the left 3 units, because in the parentheses it says x plus 3. So 0, 0 is now a negative 3, 0. Negative 1 is now at negative 4, because again it's moving 3 spaces to the left. And then this point right here is moving 3 spaces to the left, so it ends up at negative 2, negative 1. And then negative 2, negative 4 is 1, 2, 3. Here, negative 5, negative 4. And then 2, negative 4 is now at 1, 2, 3, at 1, negative 4. I mean, negative 1, negative 4. So here's the graph of h of x. Okay. Okay, so for number 11, we start off with f of x equals x squared, which is already on the graph. And g of x is 1/2 x squared, so that means there's a vertical compression by a factor of 1/2. So that means that all of the y values on the blue graph are going to be cut in half. So this point up here, instead of being at 2, 4, is now going to be, the y is going to be cut in half, so it's going to come down right here. This point right here that is at 1, 1, well, the 1 is going to be, the y value, the 1 is going to be cut in half, so we have a point at 1, 1/2. The 0, 0 stays 0, 0, and then on the left side the same thing. Negative 1, 1/2, and negative 2, 2. So the graph of g of x is wider because there was a vertical compression. So this is g of x. Okay, for h of x, there's a horizontal compression. Even though you see a 2 there, remember, the b value is counterintuitive. So even though you see 2, we think horizontal compression by a factor of 1/2. So that means that all the x values on the blue graph, because we're starting off with a parent function, the f of x, the x values on that graph are going to be cut in half. So what that means, that this point right here, instead of being 1, 1, you cut the x in half, and you're going to end up with 1/2, 1. And then on the opposite side, same thing, negative 1/2, 1. And then this point up here, which is 2, 4, we cut the 2 in half, that gives me 1, 4, and on the opposite side, the same thing happens. So the graph at 1, 0 is still 0, okay, 0, 0. So you connect the points, and it's a much skinnier graph. And this is h of x. Okay, so number 13, f of x is already on the board, on the graph. Absolute value of x, it's a v, the v function. So for g of x, it's asking that you translate it down 1 unit, so everything moves down a unit. So 0, 0 is now 0, negative 1, and then we could go from there. Connect. And there's g of x. Now, when there's more than one transformation in one function, I usually write down the points so that I won't mix myself up. So here you see the 3 points that are, they come straight from the table for the absolute value function. I did not get all of them because it's not necessary to get all of them. So these 3 are enough. These are called reference points. And if you notice right above the x column, I put plus 3. And that's because in the absolute values you see x minus 3. So the h value is 3. So that means x is being 3 is being added to the x's. And then above the y column I put times 3 because there's a vertical translation by a factor of 3. So the y's get multiplied by 3. So when you simplify this, you get 3 minus 1, and I'm just going to just do it in my head. 3 minus 1 is 2. 3 times 1, I'm going point by point, is 3. Then I go to 0, 0. 3 plus 0 is 3, and 3 times 0 is 0. And then last point, 3 plus 1 is 4, and 3 times 1 is 3. Okay? So plot that. 3, 0, and then 2, 3, and then 4, 3. So it's still a V shape, it's just a skinnier V shape because there was a vertical stretch by a factor of 3. So there's your h of x. Okay, so 15, f of x is already on the graph. Notice how because of the negative in front of the radical, there's a reflection over the x-axis. So I've got the point 1, negative 1, and 4, negative 2 on the graph. 0, 0 remains 0, 0 because it doesn't have, 0 isn't positive or negative, so it stays put. For g of x, it says square root of x plus 1. So there's no reflection here. So the parent function moves to the left 1 unit. And again, how do I know that? Because inside the radical it says plus 1. So what used to be here at 0, 0 is now at negative 1, 0. What used to be 1, 1 is now 0, 1. And what used to be 4, 2 is now 3, 2. So it goes like this. This is g of x. Okay? And then h of x, there's a horizontal translation 2 units to the right, and 1 vertical translation 1 unit up. So if you think of like the right 2 and up 1 as being your new 0, 0, we can put the first point on 2, 1, right there, and then just use, we know that it's going to go to 3, 2, and then it's going to go to 6, 3. Like that. And this is h of x. Again, if that doesn't make sense, you can always start with reference points, x, y, and it's 0, 0. And these come straight from the booklet. And so what we're going to do is we're going to add 2 to the x's and add 1 to the y's. Okay, because h is your x and k is your y. So then 2 plus 0 is 2, 1 plus 0 is 1, and then 2 plus 1 is 3, and then 1 plus 1 is 2, and 2 plus 4 is 6, and then 1 plus 2 is 3. So if you compare what I have here with the graph, they're the same exact points. Okay, so this is another option. If the way I showed you first was not clear, then just go to the points. Alright, so number 17, for f of x, we already have it on the graph. It's the parent function, 1 over x. Again, it's exactly what you have in your booklet. For g of x, for that one, we are going to translate everything down 2 units. So that means that we can start off by bringing the asymptote down. So let me use the same color. So it's going to go right here, and this is going to help us when we graph our branches. Okay, so this is the new asymptote this is the asymptote for g of x. So then the curve would go down 2 units. And down 2 units. Okay, so the pink curves, the pink branches, that's g of x. I know this is going to be really confusing when I put the third one on, because it says that I'm going to move the